Good. Maybe we can go ahead and get started.
Yeah, sure.
Awesome. All right. Well, thank you everyone for joining us. And we have Tarek and Antoine from Bluwr. I'll let them introduce themselves probably a bit better, but today's webinar will be going over Bluwr and Blumycellium. Yeah. And saying on how they use ArangoDB for all the things, but I'll just let them explain it and then take over from here. Thank you again, Tarek and Antoine, for joining us.
Thank you. We basically like the short version is that we use ArangoDB for everything. That's really true. Yeah, so my name is Tariq Dauda. Actually, I started using ArangoDB a long time ago. I'm the original developer of PyArango. And with Antoine, we founded a company called Bluwr. And we're basically developing a website for writers, readers and writers. And I'll talk a little bit more about it during the presentation. And it's quite tricky. Like there's a lot of technical aspects that we have to figure out to basically implement it. And ArangoDB comes in very handy because it's super flexible and super fast, and it's basically great. So we never had to. We started using ArangoDB and we never looked back, basically. So the presentation today is about Blumycellium, and Blumycellium is a tool that basically we use for automating everything that we need, because there's a lot of small stuff that we need to automate, and Blumycellium allows us to basically do just that. And now, Antoine, if you have, I know that you're very busy at the moment, but if you want to introduce yourself, if you have like 5 minutes.
Sorry?
Yeah, or I can do it. It's just like a
no.
Yeah. Okay.
Yes, please.
Sure. Okay.
It's complicated, but I can present myself in 2 minutes. Antoine, as Tarek mentioned, we co-founded Bluwr. He's been working on this for a few years, and we've been working together for like at least 2-3 years together, while having our jobs, and it was a bit complicated. So I quit my job in January 2021 to focus entirely on Bluwr for approximately 7 months. And now I'm part-time DevOps for a company that does AI, provides AI services. So I'm still mostly working on Bluwr. That's pretty much it.
Yeah. Thank you. So welcome everybody to our presentation on our tool, the in-house tool that we developed for automating and saving a lot of time. It's called Blumycellium. So what is Bluwr, first of all? So Bluwr is basically a text-based publication platform and we're basically trying to bring back the feeling of reading a journal from the early 19th or 20th century into basically now. So it's entirely text-based. It's presented in columns. It really looks like a journal, but like with a new design. It also has like everything that we used to have now, like views and like you can. I mean, it's a little bit like a social network, but with like we really damp down the social aspect, so you can basically be alone with your journal like people used to be. So that's how we envision Bluwr, like as a calm space for basically reading and writing, and it's entirely text based. And the thing is that readers would be able, our idea is that readers will be able to find always interesting things to read. And we also have like an in-house algorithm that basically for writers enables writers to find an audience right from the get-go. Even if you have 0 followers, if you write something that's good, usually you should be able to get attention because for your post, basically. So that's what we're trying to build at the moment. And it looks simple, but it's quite a complex application. So you have like user inputs, and you have Bluwr, and we're hoping to be able to serve like millions of users. So it's that's what makes it really complicated. So you have user inputs goes into Bluwr, and then user inputs can be like a different things. That could be like, for example, delete my account or something like that. And we also want to get stats, reports, emails, notifications, and all those those applications basically are things that we can that can be automated basically, and it's better if they're separated into different different code bases basically, so they're smaller and easier to maintain and to develop. So for Bluwr, we basically want to automatize a maximum of stuff. We want to run a lot of processes asynchronously. We want to simplify our development, and we want to be able for and everything, like it's something that's very important to us, like being able to quickly identify bugs and reproduce them, because it's like very important for the application to be like very reactive and be able to correct everything. And we also want everything to be lightweight for reasons of development, because we basically don't want, we're trying to minimize the overhead at every level basically. And so this is what we're trying to do, and trying to have something that will work like for millions of readers and writers, and be a very, very robust system. And for doing all that, you, for example, if you have like, you want to collect some stats, that can be like a complicated thing of job orchestration. So you have a database, and you have several levels of processes that run one after the other, and then you generate a report. So you have all this job orchestration that you have to keep in mind. And there are several technologies that allow you to do that already. So you can have, for example, a Kubernetes cluster with containers and REST APIs, and you have all those different parts of your application that talk together through an API. You have Apache Airflow, and you have, that's more for ETL applications. You have basically like async IO and Celery for Python, and all these different technologies, they don't really fit our need. Kubernetes, Docker, and REST API is extremely powerful. It requires a lot of DevOps skills. It's not that we don't have that, but it adds like a lot of cost when it comes to development and infrastructure. So it's not something that we always need for every kind of asynchronous application that we might have. Then you have Apache Airflow. Apache Airflow is more for ETL applications, so it don't really fit our needs. Then you have everything that's multi-processing in Python, like async IO and Celery, and these are basically like, they have no graphical user interface, like, for example, what Apache Airflow offers, and it also like forces you to have everything in a single app. And we want something that's actually more flexible, and that allows us to work like small scale things without having to rely on a big Kubernetes cluster. And this is basically what Bluwcylium allows us to do. So we have a graphical user interface that's provided to us by ArangoDB, because ArangoDB comes with a very nice graphical user interface that really that can really serve a lot of purposes. It's purely in Python, so there's no overhead when it comes to learning new skills. It's very quick to learn, and it's also very, very flexible. So you can have you can separate your application into different processes, or you can have like separate applications, and it will work exactly the same. So the mycelium, basically what the mycelium is a data structure that's in the middle of all our agents. So we call our agents elves. So they're machine elves. And right in the middle, we have a mycelium, which is a complex data structure that's entirely hosted on ArangoDB database. So everything is in a big ArangoDB database. And these elves communicate together, and basically they make up like the final big application that we have, like Bluwr. And they can run asynchronously, they can run synchronously depending on the task, and they all 100% written in Python. And you can have things in one single environment if you want to. So this is usually what we do. So you can have a single Blumycelium application into a container. You have all the elves where they share exactly the same environment, and the ArangoDB database can also be inside that container. So you have really like an async application that's really ready to be deployed in a single container. Or you can also have, like, it's super flexible, so you can also have your database somewhere else. So it can be in the cloud, can be in another container, and you have all the elves that connect to that database and share all the information that they need through that the database. Or you can also have like elves in different, each one is in its different environment, and it also would work. So that's the really cool thing about Blumycelium, is that it's really agnostic when it comes to the architecture and how you want to organize your code. So you can really find like the best architecture that fits your needs, basically. So the way it works, so the API for Blumycelium is basically pure Python, and the way it works is that basically the inspiration was PyTorch. So if you've done a bit of machine learning, you probably have heard of PyTorch, and PyTorch does something very interesting. So it takes the Python code and basically reads it in an introspective way, and generates some variable flows, like the flow of variables, like the flow of instructions that you have to basically run, that basically make up your application. And that graph is then translated into C++ or CUDA, and then compiled so it runs faster. So basically this is what PyTorch is doing. In Blumycelium, we do pretty much the same thing. So that's why PyTorch is basically the inspiration, is that we read the Python source code, and then from that we derive the variable flow, like how each variable is computed, and also the dependency between jobs just by reading the Python code. And then everything is stored inside the Mycelium. But the difference with PyTorch is that we don't compile it into C++ or CUDA. We just like rerun the Python code. And yeah, so that's basically the idea. That's how we can have different elves communicate without having to implement REST APIs. They just communicate through normal Python code. So what's a variable flow? It's something like this. So for example, you have here, you have everything that's in dark green is stored in the database, and everything that's in light green is basically calculated at runtime. So you have here, for example, you have a 2 and an empty list. You run append, then you get a list with 2. Here, it's you multiply 2 by 4, you get 8. You append that to the list that you already have. You get a list of 2 and 8, and then you ask for the second item, and then you get 8. And this basically, it's everything that's dark green is stored in the database, and then when we need the value, everything is rerun. Basically, all this graph is rerun, and we get the end result here. Same thing for job orchestration. So each job is basically a task, and tasks in Blumycelium have to they return either a non-value or a dictionary with keys. So you have to think of the return of a task like a JSON object that's going to be stored in the ArangoDB database. So you run the first task, you get an output here, and then from that output you get the first element, like the element key, and the element key is fed into argument 1 of this task. Same thing here. The only difference is fed into argument 2, and by following this flow, we're able to say to see that basically job 3 relies on job 1 and job 2 before, and this tag is stored in the database, and we can make sure that job 1 and job 2 run before we start running job 3. Basically. So we have this big introspective mycelium that stores all the variable flows, that stores the job dependencies, but we also store the source code. And this is something that's very important to us, because we want to be able to flag bugs and be able to rerun all the flows that basically ended up with errors. So we store the source code for every task, and we also store the revisions for every elf. So every agent, the source code of every agent is also stored inside the database. And each time it changes, it creates a new revision for that elf. So we have the history of all the different codes that we wherever run through to the Mycelium. We also store the documentation, and we also store all the errors and exceptions. So if any problem occurs, we have an hash. Basically, we compute a hash for every traceback, so we can extract all the tracebacks that exactly the same, and then we can have a look at the source code. We can have a look at the tracebacks and find where basically the problem is and fix it. So in short, Bluwcylium follows the variable flow from Python and also does the job orchestration for you. So it's very easy to learn. There's no need for REST APIs. You can restart from the get-go just with Python. It makes code very easy to maintain because you can have everything in the same environment. You don't have to. You can have the same Docker container because it's basically the same application, and so it makes it very easy to maintain. It's super easy to learn because it's basically like you just have to. If you know Python, just have to inherit from one class that's called machine elf, and name all your tasks with a name that begins by task, and basically that's it. And you just have to write Python code. It's also super flexible. So you can have their different architectures with how you set up your mycelium, basically how your apps are. They can be they can be different threads in the same application. They can be like completely separate Python scripts. It doesn't make any difference. You can organize your code the way that suits you the best. It allows you to break one single application into many, and this is something that's very important to us. That allows us to test basically every elf independently. So if we have, for example, the elf that will delete user accounts can be tested independently from the rest, and can be maintained independently from the rest. So that really makes it way easier to bypass. If you have problem with Python Gale, you can completely bypass it by having different Python scripts running in parallel, so there's no Gale issues. It also saves the source code for all jobs and saves the documentation if you need to go back and read it, and also save all the errors, the traceback, everything related to any failures that you might have. So. The Blumycellium is open source. It's the first open source thing that we release as a company. And so if you would like to contribute, there are some few things that we have in mind. So we're planning on building a dedicated graphical user interface for Blumycellium. Also, the next milestone will be able to run jobs directly from the code that's stored in the database. For now, the code is just stored for review. If you need to have a look at it from in the future, that we want to be able to really run exactly the same process flow that ran at a given time, because that's the end goal for storing the code in database, is that we would be able to rerun it exactly as it was run when it failed, for example, and allow us to check to identify the bugs quickly. And probably the main issue is that we haven't written all the unit tests. So if you want to help out with that, that would be greatly appreciated. And of course, it's an open source project. So anything else that we haven't thought of is fair game. So we're very happy if you have any new ideas that you think would improve on Blumycellium. And that's it. And Bluwr, we're getting ready for our first private beta. So everybody will be in the private beta. Will have the chance to see Bluwr before everybody else and test it and tell us what they think. And so the private beta is very soon. We haven't got a date yet, but we are fixing the last bugs. So it should be very soon. And if you join on our mailing list on bluwr.com, anybody that joins basically between now and 24 hours is guaranteed to be in the private beta. So thank you very much for listening. And if you have any questions, we're here, Antoine and us.
Awesome. Thank you, Tarek. And we'll just give it just a brief moment here if anybody has any questions. But yeah, definitely thanks again for walking us through that. Yeah, I'm glad to hear that you guys are going into beta and moving things forward. Yeah, I'm just kind of keeping an eye on chat here. No real questions, I think, from my end. But
if you don't mind, I can throw a quick question out there to see if we could get the juices flowing. So tell me more about your most difficult technical challenges, and perhaps you can elaborate on the methods and strategies that you're employing to tackle these technical challenges.
Yes, thanks. That's yeah, that's a very good question. So the technical challenge, the big technical challenge was basically to be able to follow the Python code with a minimum of code. Because my first idea was to implement it by having implement different operations for every basically Python function that you use a lot. There would be an equivalent in Blumycellium. But I figured out a way to don't have, so I don't have to do that. So there's just two functions, and there's just two functions working basically in tandem, and but you just see two strings, we can remember everything that's happening. So that was probably the biggest technical challenge, being able to follow the Python code without having a huge code base that would be very, very complicated to maintain. So that's the first thing, because the idea, the crazy idea behind Blumycelium was to do away with the REST APIs. It's not that we don't like REST APIs. We do use REST APIs. We have some upsells that we use, but it's not always necessary. If you have if you have to write a REST API for every little process that you write, it becomes an overhead very quickly. So for this type of things, the idea was, well, let's get a bit crazy and imagine that we could do everything just with Python. Would that be easier? And the answer is yes. It would be much easier because you don't have to maintain that REST API. So that's basically what drove us to that complicated problem that you were asking about. Yeah, I can show you some. I don't know if can you still see my screen?
Yes.
Yeah. Okay, so this is a very, very quick example of how it works. So this is not even async, async application. It's really sync. So you can do sync and async. It's basically it's your choice. And this is an elf. So it's very straightforward Python class. And the only thing is that all functions that you want to be tasks have to start with task. Basically, that's it. And then you have to give it type hints are important in Blumycelium. So especially for the return, it has to be either none or a dictionary or list or tuple, basically, because we expect either a null value or a JSON object as an output. And yeah, so that's the first one, and then the second elf is this one. So basically, this is a very, very straightforward example where you have this one basically just return the value that you send it, and this one just prints it. Super straightforward. And you initialize the mycelium this way, so you create a connection to ArangoDB using it's a PyArango object. You give it to the mycelium, you initialize your mycelium with just one function. Then we create all the collections that you need for the mycelium. You instantiate your first elf, you give it a name. This one is very important because this name uniquely identifies the elf in the mycelium. So you can refer to that elf in other parts or other scripts just by the name, basically.
Oh, okay.
And I like how you're including the word elf in this. It's very creative, and I dig that. We have a question in the chat. Unless you wanted to mention something, Chris Woodward, you were about to say something. All right. So Julie Ferrario says, "Hello, can you please also share the benefits of using Arango with Blumycelium? If you did not have ArangoDB, what would the difference be?"
Oh, it would be, in theory, you could implement a mycelium with basically a JSON file. But the problem is that would generate a very big overhead because it will be it's you could also have an SQL database. You could implement it in different ways. But the thing with ArangoDB is that it's extremely flexible. And the thing with the mycelium is that we use documents. For example, elves are documents. With source codes, we have, but the jobs, dependencies, that's a graph. And we also store, like, there's another level of inception. It's like we have another level of graphs, and that graph for computing the variables. And at the moment, this is stored as a JSON object, because it's just easier for us to just parse it afterwards. So we can by using ArangoDB, basically it makes a difference between developing Bluwcylium in a few months versus a few weeks. And that's a huge difference, because each time because by using Arango, this is like the main, like for me, it's the main reason why we use Arango as our sole database in Bluwr, is that you're never stuck. It's like with ArangoDB, it's like you always, if you imagine a way of implementing the thing that you want to implement, and if you find a better way, you don't have to change your whole stack to be able to do it. You just have to change your model in database. That's super quick. So I've tried, while developing Blumycellium, I tried different things. I tried different architectures of graphs. I tried different architectures of like different types of JSON schemas. I've tried a lot of different things before I ended up using the one that we have now. And with any other stack, that would have taken me like a very long time, because it means that I would have to install something new, try it doesn't work, install something else, etc., etc. With ArangoDB, you can just like use Arango, and that's a great point.
Awesome. Thank you, Julie, for the question. I have one more for you all, if that's okay.
Sure.
So congratulations once again on your private beta. I wanted to see if you can perhaps paint a picture for me of what the ultimate version of Blumycelium will look like. You know, when you feel like it's a weird question, because like, you know, when you're creating these things, like it's never really over, it's never really done. But I want to see if we can find and see if we can paint that picture of like at least as close to the ultimate version of what does that look like from your perspective, and also from the end user's perspective.
Yes, from my perspective, it would be. For now, it's not super stable, because we want to open source it from the beginning. So this is something we've never did before, but it's like from the get-go, we're going to open source Blumycelium. And so it is stable, but we don't know how much stable it is. For example, we haven't finished writing the test. So would be the first thing. Like my ideal version would have like a test coverage of 100%. First of all, that would be great. The second thing is, we should be able to run the code that's stored in the database. And because the idea behind Blumycelium, we have some use cases in Bluwr, but like the real genesis of Blumycelium does not come from Bluwr. Actually, it comes from another project that I had that was called ArangoFlow, and that project was mainly geared toward machine learning. And working with data sets and having several models running at the same time and things like that. And from that perspective, what I find really interesting and very important is to be able to rerun the experiment exactly as it was run 6 months or 2 years ago. And we can do that in theory with Blumycelium because we store the source code. And being able to do that would be like would be like one of the end features that I would like to see in Blumycelium.
Awesome.
Very cool.
Right, Chris Woodward, do you have any questions? Because I have one more. I have one last one, if that's okay.
Oh, you keep them coming.
Okay. So now that you're in private beta, once again, like what is sort of like your sort of like your dream goal with the community? And like let's say I joined the private beta, like what happens next? Can you walk me through what that would look like and what you have planned going forward?
Yeah, so our plan with the private beta is to present something that's almost finished. So the thing is, we're not planning on adding new features from the private beta to the public beta. be exactly the same features. The reason why we want to do a private beta is because we want to test the interface, basically. See if the interface is intuitive, if people like it, what people like, what people don't like, and then make some adjustments. And also because we want also to test it like with users, because we have, we test it ourselves, but you know, different people will find different bugs. So it's basically, that's the idea. Test the interface and find the last bugs and then move into the public beta.
Okay. And all along, like if I want to join a private beta, I just join your Discord, and then I should be able to get more information from there, or where is the best place to get information about it?
That Discord is a very good idea. We don't have a public Discord yet. We have, we have a private Discord, but we should probably open a public Discord. Right now, it's really the mailing list. So we basically, the way it works is that we gathering emails. We've been gathering emails for like 6 months now, I think, or I don't remember exactly the date, but we have like more than 600 people that are already subscribed, and from those people, we will randomly sample like a given number of people, probably like around 100 or more, depending on what we decide, like what we want to test, basically. And these people receive an invitation through email. It will be basically a link. You click on it, and it creates an account for you on Bluwr. And then you'll be able to test Bluwr as if it was like open for everybody, but it would be open just for you and the other people who have used it. And everybody that's subscribed, because it's now like it's kind of hard, like we have a webinar, so it's nice. So everybody will subscribe like in the 24 hours, probably, because these people have seen this webinar. So we will be like, we will send you you'll be guaranteed basically to be in private beta. So basically that's the idea. And yeah, and also the private beta, and this is something important. We will tell it like when you get the email, but the private beta would be really private. So the website will not be open to the public, and everything that you write during the private beta will be erased. So we won't keep any private information, anything, unless you ask us to. And for example, if you write some post and you would like to keep your account for when it becomes public, we can keep that for you, and then just like transfer your account to the public to the public version of Bluwr. But everything on the private beta will be erased 100% after like we just collect what you think, and then we erase all the information.
Okay. Very cool. I know I said I had one last question, but I lied. I have one more.
Okay.
So I'm curious to know about your features. I'm curious to know about the most difficult feature that you've accomplished, and then I'm curious to know about like the feature that you're working on right now, but it's just been really tough, and why? Why is it that feature that you're working on that's been really hard? Why is it so hard? So it's a twofold question. Like, you know, what feature was it really difficult, but you conquered it? And then what feature is really difficult and you haven't quite conquered it yet, but you're getting there? So tell me more about that journey and that story. Okay.
The real difficult one was we had issues to make Bluwr scale, basically. And this is so we managed to do that by having some. I can't tell everything because it's we must give some things private. But we managed to basically with a single instance of ArangoDB, we managed with some clever tricks to be able to handle something approximating like 100,000 users. And this is something that, like, scaling, usually people don't think about scaling at this stage, but for us scaling was very, very important, because we want Bluwr we want basically users to have the best experience always. So we don't want it to launch and then having problems with scaling and having to shut the website down or found a new way of like new architectures or infrastructure architecture or things like that. So we wanted to be scaling proof from the beginning, and I think we managed to do that. we haven't tested with real people. We tested with agents. So we have like we just launched 1,000, 100,000, 1 million, 10 million fake users that basically interact with the website. And that's the way we test. So these fake users interact with the website. They do pretty much everything that users do. So they post, they delete, they like, they do everything that normal users would do, and they do it all at the same time. And then we see if we crash or not. And we've been able to scale it. Antoine knows probably that. I forgot the number. It's like a few.
Yes, 100,000 was a decent response time. With a single instance, 1 million was starting to get.
Yeah.
And what we consider non-decent response time, like when you post an article and we do all this calculation for you, like the specific algorithm that Tariq mentioned that allows you to get an audience even with 0 followers.
Mm-hmm.
This part of the algorithm was a bit tricky to make scale, but now with 1 million users and a single machine, 4 gigabytes of memory, response time for this case is 30 seconds, which is definitely not acceptable. But it was sub 1 second for 100,000 users
with 4 gigs of RAM.
Yeah, I was going to say, I think it's kind of acceptable with 4 gigs of RAM.
When you consider the infrastructure, the power of the infrastructure, it's pretty decent. Yes.
Yeah. That's also a testament to how our ArangoDB is, how optimal it is. And one thing we when we did that test, we hadn't set up all the indexes.
Exactly.
Yes. So that was not even not even with the full indexes. It's like 30 seconds for 4 gigs of RAM and 1 million users. So it works.
Yeah. Hey, I'll take that as an endorsement. I'll take it.
That's very cool. And then like the biggest technical challenge we're facing now is Bluwcylium, basically. It's making this thing grow. It's our new thing, because Bluwr is like 98% finished at this point. So the big thing now is Bluwcylium, and we plan on moving like something that we do now with Bluwr, like code base will be moved to be done with elves, basically. So elves we just like moving some parts of the Bluwr, the monolithic Bluwr, into elves, and automate a lot of things that we have to automate now that because we will have users. And users, for example, have to send emails from time to time. So we will automate all that. And but the big challenge is to have basically to have a mycelium that works not only for us but for the community. And that's really the end goal. It's not like to have just something that works for Bluwr, but something that would be general enough to work with for different applications that the community has.
That's definitely a winning mindset. And speaking of the community, we have one more question in the chat from Ibrahim. He says, "Hello, this might be mentioned before, and I might have missed it, but what is ELF stands for? Does it stand for linkable format?" This is a great question. Thank you, Ibrahim.
No, it just stands for ELF, because like the mythology is I don't remember what we decided to call them elves, but we just like. We were looking for a name because we didn't want to call them agents, because it's everybody does that.
Yeah, that's pretty much it. We were looking for little agents in the name, and we said, okay, let's name them elves.
We're not. Yeah, probably was around Christmas.
Most likely, yes.
Most likely around Christmas, and we just like decided to call them elves. And
you associate mushrooms with elves. You know, you've seen those elves. I feel like in somewhere in Northern Europe, they have like these red mushrooms, and then you got the little elves. Yeah,
it's true. And also Smurf was already taken. So
copyright law.
So we had to go for a name that's in the public domain.
Well, I know you mentioned that you're doing some of this on open source, and the Blumycelium is going to be open source. Is any other parts of Bluwr going to be open source?
Some of them, yes. We're planning on releasing elves more and more. so that would depend on what we implement, but we're planning on having like a steady release of open source things as we develop them. We also have like a lot of tools that we develop inside that are not directly related to Bluwr, but for example, for social media, we have tools for that help us a lot, like basically make the posts and like edit videos, work with images, and these are all tools that we've developed in-house that save us a lot of time. So these tools will probably be open source at a given point. But yeah, but when you
not necessarily, sorry, oops, sorry, Tarek.
No, it's just like it's the thing is that if you want to open source something, it's not that we don't want to open source them, but there's work that has to be done to open source anything. So you have to be very careful with the documentation. You have to because when you use it yourself, you don't have to document it that much. That's the truth. But when you open it to everybody, then your documentation has to be sharp. You need to have examples that are really sharp. Everything has to be like very clean and packaged so other people can use it. And for now, we don't have a lot of time to do all this stuff because we're still like in active development and we have a lot of things to do. But for Bluwcylium, we made an exception. And because it's really cool, like we really like the project and really think that it serves a purpose that no other tool serves at the moment. Whereas, for example, the things that we use for social media, you could probably do the same thing. It's like like having an automatic Canva, for example, and a lot of people already use Canva. So it's not like it helps us, but I don't think it will help the community as much as Blumycellium.
Very cool. And the one I found is through the Bluwr-tech GitHub. Is that right?
Yeah, Bluwr-tech
yes.
GitHub.
So I wanted to mention also that if not open sourcing, we started writing tech blog articles, and we will continue to do so. So it's a bit less work than open sourcing basically a full framework, but it still allows to share the knowledge that we acquire while building all these stuff. So for example, when we do some tricks with the infrastructure code, we have everything automated with the Terraform. So for these kind of projects, instead of writing a full Terraform module, we will post blog articles. We already did one of them for remote working, basically, and sharing all that. So this, even if not open sourcing, we will find an easier way to share the knowledge we have.
Share the knowledge.
And that's just like through Bluwr.com?
It's blog.bluwr.com.
Yeah, blog.bluwr.com, yes.
Yeah,
blog.bluwr.com.
Okay. Yeah. And we also sell t-shirts.
Well, if you start selling t-shirts with the Bluwcylium logo on there, I don't think I can hold back. That's
okay.
I'm liking it. Yeah. No, I also like the other one. Yeah.
Thank you. We'll think of a design with the Bluwcylium.
Yeah, that's a very good point.
We haven't thought of it, actually. You're the first one to give us the idea. Yeah. And one thing I'd like to show you about the source code. It's like, you see, like it's normal Python code, but the thing is that everything, like when you write this code, it's stored in the database, so it doesn't run. Well, we have, but Blumycellium has things inside of it that basically, like if you give it the types, it can detect errors before running the code, so it doesn't have to run the code basically, and the code only runs when you do start job. So all that basically all these instructions, basically what they do is just they store everything that needs to be stored in the ArangoDB database. And then by calling start jobs, pulls them from the ArangoDB database, and then runs the code.
Very cool. Yeah, I'm definitely interested to get in there and check it out. I think having having something like this in order to set up like these tasks running. It's an interesting approach. I want to get in there and play with it just so that I can better visualize it in my head. You know what to do.
Cool.
But
yeah, cool. And I know you're very good at finding bugs. So.
Yes.
That's even better.
Yep.
Yeah, definitely. Anytime you can set up a call, and then and we can start playing with it together. And you tell me what you think. And if there's anything you think we should improve on, we open to any suggestions.
Cool. Yeah, definitely. Well, otherwise, I think we've run out of questions, and wrapping up to the end. Definitely, thank you both again for joining, and you know, as always, we're always happy to have you giving a talk with us, and yeah, I'm excited to see where it's going in the future, and I'll be making sure to go and sign up in the next 24 hours, and
thanks a lot.
make sure I'm a part of it. I think I'm already signed up, so I don't know what will happen there, but I'll sign up again just to make sure I get in that sweet spot.
Okay, thanks a lot. Thanks a lot. Thank you for having us. It's always a pleasure to present at ArangoDB webinars, and thank you for making ArangoDB, because without ArangoDB there would be no Bluwr. So thanks a lot for making such an awesome database.
Really quickly, how can people stay in touch, follow up with you on socials and all that good stuff, by the way?
Yeah, you can follow us on Instagram. It's Bluwr official, and you can also follow us on Twitter. Same thing, Bluwr @BluwrOfficial, or you can just go to the website bluwr.com, and then you'll find everything: our Twitter, our Instagram, the mailing list, everything is there.
Awesome.
Oh, and I got to give a shout out to the Instagram. I just happened to check it out today, and Bluwr Instagram. That's where it's at. High quality content happening there.
Oh, thank you. Thanks a lot.
Thank you very much.
Yeah.
We're doing our best. Thanks a lot.
Yeah. Awesome. Yeah. Thanks, everyone.
Thank you.
Have a good one.
Thank you.
You too.
Bye.
Bye.